related to the milk value chain. First of all, I would like to apologize for the technical problems we had last week with the server provider that forced us to postpone the webinar, but we have already a new date for this webinar. It will be the 2nd of October, so we invite to all the participants interested in the efficiency energy in the food industry to also participate in this webinar we have the next week. Before we start, I would like to inform to all of you that this webinar is going to be recorded and later uploaded in the VIDA website. I also need the approval of all the speakers to share their presentations in the VIDA website. Are you all agree? Speakers?
Yes, I agree.
Yes, me too.
Yes, we do.
Yes, I am also agreed. Yeah.
You also will find here in the right side of the window a chat where you are able, all the audience is able to send their questions, and we will answer it once the webinar will be finished. So during the webinar, first of all, we are going to present the VIDA project and its objectives and its financing schemes through 3 different types of vouchers. And we are going to especially focus on demonstration vouchers since we are now already immersed in the second call of this kind of voucher. Later, Peter Jong is going to explain the main challenges in the resources efficiency in the milk sector, and 3 SMEs, NSM, Eco, Grandstoffen, and VDH Water Technology will present their innovative solutions for the challenges in the milk industry. VIDA project aims to accelerate the implementation of innovative technologies in the food sector, which suppose an improvement in the usage of water and energy. VIDA is an innovative project that during its lifetime, that is from the 2018 April to 2021 March, will support the SMEs through cascade funding to develop their innovative ideas. We count with more than 3.3 million to fund the solutions for the agro-food sector efficiency through three different voucher schemes, considering their different level of technology readiness level. The consortium is integrated by 10 partners from 7 different countries. All projects must be showcased in the VIDA Nexus. That means that solutions have to be focused and enhance or boost the efficiency of water and energy resources in the agro-food sector, and integrating when it's necessary the key enabled technologies. Okay. The requirements for the entities that aim to participate in the VIDA calls and convert in a VIDA beneficiary are the 4 issues that are shown in the slide. First of all, the entity must have the SME status according to the SME check from the European Union and declare their financial stability. The activity of each of the SME must be also focused in the following sector: food, water, energy, or the key enabled technology sector. And the applicants must be a member of a VIDA cluster or be headquartered in a VIDA region. In this map, you can see the regions in which the SMEs must be allocated in case they want to apply to a VIDA voucher. The funding scheme from VIDA project is divided in 3 different possibilities. It depends on the TRL of the technology. and all of them cover the 100% of the eligible cost, considering the maximum amount of budget from VIDA project that each SME is able to get is 60,000 euros. The budget for the innovation support voucher is up to 5,000 euros, and these vouchers are focused in support the access to external knowledge. In the case of validation vouchers, the budget is up to 25,000 euros, and its objective is to demonstrate the performance of the technology that the SME wants to validate by external validation. In the case of these schemes, they are both actually opened until the budget will be exhausted, and both aims to support the subcontracting of activities. Up to the 100% is allowed for innovation support voucher, and a minimum of 75% of the budget of subcontracting activities is mandatory in case of validation vouchers. The third financing scheme is demonstration voucher, in which we are going to focus during this webinar, since I have already said the second call is now opened until the 31st of October. The budget of these vouchers is up to 250,000 euros and requires the collaboration of at least 2 SMEs. These SMEs must include a prospective user in which facilities the technology has to be demonstrated. The eligible costs are remarked in the slide, and please note that in this case the subcontracted activities must not exceed the 50% of the total budget of the proposal. These demonstration vouchers are divided in 2 different calls. The second call, and the last one also, is already opened until the 31st of October, as I have already said. So we encourage you to collaborate through the VIDA networks, through VIDA Webinars, and through all the VIDA activities for boosting the networking between the SMEs in the VIDA regions. The duration of this demonstration vouchers project is between 6 and 12 months, and the TRL must be between 6 and 8. Regarding the review of the actual state of part of the proposals and funded projects in all the VIDA vouchers, we find that 22 proposals were submitted for innovation support vouchers and 13 were funded. In the case of validation vouchers, 15 were submitted and 7 funded. Please, we want to remind you that the next cutoff date for this kind of vouchers is on the 30th of September, just in 5 days. So we encourage you to send your proposal for this voucher. And in the case of demonstration vouchers, we have, sorry, here there is a mistake. 45 proposals were submitted and 8 proposals were funded, which suppose a total of 1.5 million euros for supporting the SMEs through this voucher scheme during the first call. In this project, there are in total 34 SMEs involved, and 5 projects emerged from the cross-border collaboration between clusters. So again, we encourage you to use this network and collaborate. The projects are targeted in different food sectors and tackle different challenges, such as water, nutrient recovery, or green agriculture. You can find all of them here in the slide. For applying to the VIDA demonstration vouchers, you have to go to VIDA website and review all the VIDA terms and conditions that have changed in this call. The VIDA terms and conditions have some modifications related to the first one, and also you have to revise the guides for applicants. Later, you have to send an email to the direction you can see in the slide, then with the information about your name, surname, country, company, and email address to join the platform Cloudfight, which will serve to you to upload later your presentation. Later, you can find in the VIDA website the application form and download it and complete and save this form. And once you have finished it, you have to upload it in the Cloud5 platform in which you have already registered before. Once you have sent or submit your application, only VIDA consortium members have access to it. The evaluation process, as I already mentioned, is divided in two calls. Now we are immersed in the second and last one. So the evaluators of the demonstration vouchers review each proposal and is formed from an independent VIDA advisory board. During the evaluation, each person will check the eligibility topics, the capability of each proposal, and finally, they are going to evaluate the excellence of the proposals they have received. After a maximum of 10 weeks, the proposals will be evaluated. In case of those proposals that are awarded, we have to previously sign the contract, and once the contract is signed, the project is able to begin. And in case of rejection proposals, you will have the feedback and support from your VIDA regional partner or your VIDA sponsor. So here you can find all the clusters that are involved in the VIDA project. And now, please, Peter, you can continue with your presentation about the milk sector challenges. Thanks. Peter? Hello, Peter, do you hear us? Here? Peter, can you use the chat to communicate with us if you have any problem? We can't hear you now. But I see that your microphone is unmute, so I don't know what's the problem. Please use the chat. Okay, we will wait till Peter gets in the platform again.
So,
Yes, Peter, it's making noise, so I don't know what's the problem. Get into the webinar again. He writes, I will start from the beginning. But Peter, are you here? No, you have left the webinar. He solved the sound problems. We will continue presenting the solutions for the challenges in the milk sector. So the first one is Antoine Frame from NRSM, and he's going to present their solution. So please, Antoine, are you here?
Yes, I am. Hope you hear me.
Okay, so I will charge your presentation. Yeah, that's the beginning. Hello, welcome. So you can start with presenting your solution.
Hello, thank you very much. So I'm Antoine Fram, and today I will present the NRSM speech. And I would like also to thank you, Maria, for the opportunity to present my company. So we are a small startup created 3 years ago, and we are a spin-off of Politecnico di Milan, which is the first Italian university, and we are dealing mainly with energy savings in industrial sector, and we try to give value to monitoring data. So if they're existing in the field, we use them. If not, we install new one at the right position. So I think everybody knows that energy in the food and beverage industry is a hot topic, and I think it exists. A lot of reviews say that it exists a large energy saving potential in milk and dairy, and we see it. And also we notice often inefficient use of fresh water for cooling, so there is a lack of relevance and significant data, and this means we have a lot of missed opportunity for energy and water savings. So what we developed in the last years is a prototype to organize, archive, and analyze the data, the monitoring data. And by doing this in a proper way, we enable different services like energy intelligence, optimization and predictive maintenance, and advanced analysis such as pinch analysis and heat recovery and saving in cooling. And in particular, optimization and predictive maintenance means we analyze in detail some main components such as chiller, cogeneration, boiler, heat exchanger, heat pump, or heat recovery system, and we analyze them, how they perform in the time, and we try to find some potential optimization. And I will present two examples. The first one is the chiller. So we analyze the chiller in an agri-food company, which is where we compare the measured efficiency with the predict one, and we see that it performed more or less as expecting. But we propose an optimization of this chiller, which was to optimize the condensation temperature according to the weather temperature, and this allows a saving of 45,000 euros. The second example is for cogeneration, which is most of the time cogeneration are controlled based on electricity load. This means that during the day there is some period where we have some waste heat and some period where we are missing the heat. So our proposition of analyze allow to propose an optimal management of thermal load through thermal storage and load control. And this allows a saving of 30,000 euros per year. But once we organize properly the data and we know how the process is behaving, we enable the deep analysis, mainly on the process, and which is allow us to understand where is potential recovery, where are the hot stream and where are the cold stream, and by matching these two streams we are able to get very large saving. And for instance, for a large top layer cheese factory, we managed to save 6,000 euros per year, and also to optimize an inefficient use of fresh water for cooling, which is saved 9,000 cubic meters per year. We also work or develop our knowledge with a big European project, which called TTG, and the objective was to optimize environmental performance of the different process phase of hard and semi-hard cheese production. NSM is dealing with the dairy phase, and what we did is we did the energy analysis and benchmark of 26 dairies in 4 EU countries. Now this phase is finished, and this analysis is finished, and what we try to do is to transfer this knowledge in a web application tailored to industrial user needs for product environment footprints and reduction and energy savings. And we expect savings of between 15 and 25% for thermal saving and 10 and 20% for electricity. The specificity of NSM is to combine the domain knowledge and also the new techniques such as machine learning or the ability to model the system. This is our team. So, and what we propose in the VIDA proposal is to develop a software product for software as a service delivery to food and beverage EU clients, and to strengthen business opportunity in VIDA countries. So the current situation is we have two partners in Italy, NSM and Optimo, who is dealing with IoT, and we are looking for a demonstration site in dairy, milk and processing factory. We are also open to consider the opportunity to join the effort with other subjects for a shared demonstration voucher proposal in line with our objectives. So thank you very much, and thank you again for the opportunity.
Antoine, for your presentation, and I hope that you will find the partners you need for your proposal, and that this webinar will be useful to get it. So now Peter de Jong is again connected.
Yes, I'm here. Can you hear me?
Yes.
Okay, that's good.
So follow your presentation about making the challenges. Perfect. You can begin. Thanks, Peter, and thanks for your presentation.
Okay. Well, my name is Peter Deel. I'm a professor of dairy process technology at Van Lagenstein University in Leeuwarden. And I'm a principal scientist food processing at NISO in Ede, also in the Netherlands. I want to talk with you about efficient ways for milk production. And I cannot ignore that the sustainability aspect has a big influence nowadays on the technology development in processes, not only in the factories but also in the entire chain, the production chain of milk and milk products, as the CO2, as you all know, in the atmosphere is increasing. Whatever that means, we have to take some action that's believed with the society. And therefore you see this type of calculations or estimations of footprints. For example, a carbon footprint for 1 kilogram of cheese, the water footprint, and also the cost is in this table. And the first remark is, if you see the product, so the cheese itself, it has a footprint of 9 kilogram equivalents of CO2. But if you just look at the manufacturing, so what's happening in the factory, that's only a small part compared to the entire chain. And that the same holds for the water footprint and for the costs. So that's something to take into mind. It doesn't mean that it is not important to improve the manufacturing, so all the processes that takes place in the factory and in transport and so on, but you should be aware that you cannot solve the entire problem by just applying some technology. Where does the global warming potential come from? Well, just a few words. That's from the methane, that's what's told. But everything is depending on the amount of cows and how you are doing the farming. And if you have just one cow at 1 hectare of grassland, then there is no problem at all. Then you capture more CO2 than the amount of methane and CO2 that's coming from the cows themselves. And again, here you see that 10 to 20% of the total global warming potential in milk industry is coming from the processing part. I'm in favor of milk products, I have to admit. And if you compare, for example, different products like orange juice, soy drink with milk, you look at the CO2 footprint, but you compare it to the nutritional value, then you see that milk is relatively sustainable if you compare it to the other products. And that has to do that it's a very nutritious product. In fact, it's I think it's the only product in which you can live a whole year long without that you will die. If you have a diet of only orange juice, you will die within a couple of months. So milk is a very good product. Also, if you compare it with processed plant proteins, that costs also a lot of industry to make it, and it's also a little bit of a joke, but some truth is in it. If you look at the cows, they are also, you could say, small factories, and agro-feedstock is coming in, grass. They need some biofuel, well, that's also grass, that's the energy, that's the input. And they deliver milk, which actually is processed plant proteins. And after a couple of years, if the production becomes too low, or then you just eat the cow, and again you have a very good meal. So that's the idea behind it. But nevertheless, it's important to incorporate sustainability in all your designs and technology development. And so in the past it was mainly cost driven, then quality becomes more and more important, and I think nowadays it's not only cost and quality but also sustainability has to be taken into account if you are evaluating different types of technologies. Okay, well, the outline is actually these 3 points I want to discuss in a couple of minutes. That's the optimization in the dairy industry, and the innovation. What's the difference between these two, and what should we focus on? The examples of sustainable efficient technologies, that will be the main part, so what's already done and what's in development that might be of interest. And also the new way of process design, how to look at it. Well, this is another way of presentation, and again you can see that, well, in this example you see that in the milk chain 73% of the carbon footprint is in the raw material production, so at a farm. So where to start if you want to decrease the footprint of milk? Well, you can go for optimization or innovation. You can improve in the old or go for a complete new way of processing. And we have to admit that in the food industry and also in the dairy industry, we are a little bit old-fashioned, and that has also to do with the complexity of processing food material. It's not a chemical with a known composition, but the composition of all these materials like milk and grains and so on, that this composition is differing from time to time, and also the quality, especially microbial quality, is changing all the time. So what you see in the focus in the industry, in the factory, is the low risk optimization of your current process design. For example, replacing your old pumps by more energy saving pumps or something like that, but the core of the process remains the same. But we have to be aware that this has some implications, and sorry for the Dutch, I missed this one. I have to, but this is in Dutch, but I will explain. In the dairy industry, you're mainly focusing on minimizing costs, as I said, and so make a little bit improvements. So actually, we try to decrease the shape of, how you say, the red footprint, so to say, to decrease it. But there is a limit to it. In the end, you have optimized everything, and well, you make very small incremental improvements, because you have reached the theoretical optimum you can reach with your current process. So you need new processes, you need really new technologies, and that has also some risk in it, because you don't know on forehand what will happen if you introduce, for example, although it's not really a new technology anymore, but even nowadays, membrane technology, well, it's not an easy process, and most of the time you have to change your way of processing, and there's some risks. You not always know on forehand what will come out of it. So I would advocate here that you have to cooperate as manufacturers of milk products, but also as technology providers, because the risks are too high. There's always a chance that it doesn't work. And well, yeah, how about innovation power? Again, this is in Dutch, but some processes are not changed that much. If you look at the drying principle of food, drying of fish or pasta, it's thousands of years later, it's still done in the same way. Of course, we have made some steps in the last couple of, well, decades at least. But still, if you come into a brand new cheese factory, well, the steps are the same, and there is not real innovation in there. So I want to move now to some examples of new technologies, new sustainable technologies that are under development nowadays. And the first topic is on mild processing. So this technology it's called EASY or ISI technology, and it's based on steam injection. And actually, in this way you get a very short treatment of your product. As you can see, you enter the system with 60 degrees C, and then it's heated to 160 degrees within half a second, and then the next half second is, oh, something is going wrong. It's cooled down. So that means the total treatment lasts less than 1 second. And this gives nice opportunities. For example, we made pasteurized milk, which tastes equal to normal commercial pasteurized milk from the supermarket, but it has a shelf life of 60 days. You can also apply this technology for making, for example, raw milk microbial safe, and still have maybe not all, but most of the advantages of the raw milk, in terms of protein, functionality, and all type of nutritionist things. So this is a new technology that we try to develop also here in Leeuwarden. Another thing is that it's more from a quality point of view and a nutritional point of view. That's, of course, you know, if you make infant formula, it's very important that you get rid of all the microbes that can harm little children. So what you see in the infant production of infant formula, that the heat load of these products is very high. The product is heated above 140 degrees C for a long time, also at lower temperatures, so that in summary the heat load is very high. And okay, it's microbial safe, but something different will happen that has some implication on the nutritional value, as you can see. So, and that's the reaction between the sugars, lactose, and the proteins. So the digestibility of proteins will go down, and that means that, well, that can at least harm little infants, and even can be the cause of allergenic reactions. So that's something you don't want, and it's a hot topic nowadays in infant formula production. I think you all know that, especially when you compare it to the petrochemical industry, that in the food industry and the dairy industry also, you have to clean quite frequently. There's run times of, let's say, 8 to 10 hours or 20 hours for evaporators, but then you clean for 1 or 2 hours. So that's, in terms of efficiency, that's undesired. You can, but also in terms of footprint, because you are losing product by cleaning. So we want to avoid the amount of fouling in all these equipment. And well, one new technology is that you use ultrasound applications. So you apply speakers to with ultrasound high frequency sound to the heat exchanger, and what we see is that the amount of fouling deposits is decreased by 50%. And this is actually a movie, but I don't think it will work. But what you see here is a plate heat exchanger, and I'm not sure if you are familiar. Here you see a drawing of this heat exchanger, but the speakers of the ultrasound are connected to this heat exchanger, and what you see is that there is the whole equipment is in vibration, but very small vibration. You can see that the graph below, it's in the terms of, let's say, 1 or 2 micrometers. And in this picture, you see green spots and red spots, and the green spots means that at this particular moment, there's part of the surface is going to your direction, and the red part is going from your direction, and this is vibrating all the time. And in this way, you are hamper the amount of fouling before in this heat exchanger. Well, another not real new technology, but the applications are increasing more and more, is the separation technology, and especially membrane separation that's applied in the dairy industry. It was started to well, to concentrate, for example, by reverse osmosis and nanofiltration. But you also see now applications in fractionation. So to, for example, to fractionate the whey proteins from the caseinate, or even to fractionate different whey proteins. And this is a very important technology to get value from the whey products. And the whey is a side stream by cheese production, of course, and nowadays they earn a lot of money with whey products, and that has also to do with membrane systems. Yeah, that's in Dutch, but for example, also what's called microfiltration is applied to remove some microbes from the raw milk beforehand, so that you get a longer shelf life. But also there are new technology, complete new technology, because also in the membrane separation technology, fouling is a big issue, fouling of the membranes of the filters. So there was some people in Wageningen, they invited rotating microsieves. You see here a picture of the sieve itself. It's very nicely, the pore size distribution is very narrow, as you can see. It's just made also by chip technology, like in computers. So you see it's very, well, all the pores have the same sizes. Here you see some, I think it looks like bacteria on the top. But also on these sieves, fouling occurs. And what actually is done, you have some vacuum, well, you have a rotating sieve, and you have a vacuum system, like in the household, you could say, and then that is removing all the fouling from the membrane, and then in the end you get much higher fluxes. Well, the challenge here is how to upscale this to tons per hour, because this size now is like 20 centimeters in diameter. So, okay, you need some upscaling, and there are also some microbial issues, as always, but they can be solved. Yeah, I'm approaching the end of my presentation, and I have now another important development is the use of computer models. Computer models that connect what's happening in the process with what's happening with the product. So what you see here is just an example of a simulation a system which was developed by NISO Food Research in Ede. And you see here some, well, temperature time profiles that are in the process, and that are this is inline system. And what you also see what's happening, for example, with the bacteria or with the whey proteins. You can see it inline. So this means that you can just control your product quality, but also the costs. And the system is designed in such a way that you can connect it to your process inline, and that you can also diminish the amount of fouling by just the optimization of the temperature time profile. An important thing there is how to validate these models. These models have been validated, but in practice, as I said in the beginning of my presentation, food materials are quite difficult. There is a variation in the composition and so on. A lot of things are varying. So you need some validation, and preferably during processing itself. And that can be done by sensors, inline sensors. And that's also a very important development. You see a lot of sensor technologies popping up, also from other areas like medicines and pharma, and even from the army, I would say defensive research from the States, America, and all these sensors are looking for application. And well, I think the future will show that the computer models, and in combination with inline sensors, will have great opportunities for increase the efficiency of dairy process in the future. Okay, then I will end with some conclusions. The first one, that you should really, if you do some innovations, you should focus on the total production chain. We have seen that the main carbon footprint is in the farming part, so in the primary sector. But also, it's important that you the whole production chain will have benefit from innovation. That not one party is paying the price and the other party has the benefits. The second point is that if you want to make innovations, to develop innovative process technologies, we have to develop it together, and it's very important. And well, process technology is not that competitive like new product formula, so you can do it. And I have seen a lot of examples, and maybe also in this European network, it might be also an example of doing this together. And always, that's a more general point, be critical, because there are a lot of discussions going on in society that made always your own calculations and based on facts. So that's the thing I want to share with you, and I didn't hear anything, but that's logical in this webinar. But I hope that you enjoy it, and if there are some questions, so I'm open to questions. You can also see my email address, so if you have more extensive questions or private things, you're more than welcome to come in contact with me. Thank you.
We also consider yes, thanks. Thanks for your presentation and your explanation, and I'm sure that this will help to all the SMEs to identify the main challenges for the innovation in the milk sector and the different approaches for facing these challenges through innovative solutions. So before we continue, since we have Antoine has to speak before we expected, maybe Antoine Frame, do you want to add something to your pitch presentation after the explanation of Peter about milk industry challenges?
No, so I think it was very interesting, and I agree that it's crucial to do compute model and sensor and to understand what happened and to follow what happened in the process and try to anticipate and to understand what happened. I think is crucial. So I agree. I was nice presentation. Thank you very much, Peter. But I don't know what. Nothing else to add.
Okay, thanks, Antoine, and thanks again, Peter. Now we are going to continue with Elma's presentation about Rhine-Tech Refinery, how Rhine-Tech Refinery helps to dairy production, dynamizing the nitrogen losses. So I'm going to charge your presentation, Elma. Yeah, it is. So welcome, Elma. You can begin with your presentation.
Can you hear me? I hope you can hear me. Hello?
Yes, we can hear you.
Hello? Can you all hear me?
Yes, we can hear you.
Thank you. I'm very happy with the presentation of Peter de Jong. He is stressing at innovations in the whole of the dairy farming till milk production industry, the whole chain. And my presentation will be a smart one. I've written down some words about that because we are helping farmers, not the milk production industry, farmers to do a simple separating technology, which is smart, environmentally friendly and proven technology. It's about a milk innovation, that's the M from smart. It is an available, because contractors are working it and doing some production with mobile technology for us, for eco-grondstoffen. It is called Reintech. This is the R from smart, and it's rich in solutions, also outside the milk sector. So I think it can be installed quite quickly, and we would love to work with VIDA for testing and discussing this kind of technology. I will now try to explain what it is. Okay. Eco-grondstoffen is a trades organization. I am the director of it, and we work in this sustainable and profitable dairy farm chain by refining the autumn grass, third and fourth cut of the farmer. We have been welcomed by Test Farm, which you see here. It's on the sand, and it's just in the Netherlands been recognized as a new testing farm for sustainable problems and climate solutions. And we work with the Reintech technology, which means that I will show you the machine later. On this farm, the grass which is mown directly will be put into this machine to do biorefinery, which means that you split the material, the grass, fresh grass, into fibers and protein-rich juice. Then the protein-rich juice will be fed to the 150 cows which are placed here, and also to some groups of cows of the KVA, which is a group of dairy farmers working at improvement of their farms, together with Courage. Courage is with Karel de Vries, a very known dairy innovation farm organization. We have changed our proposal because we got some commands a bit. I will come back later to that. Here is the Reintech mobile installation, which has been built a few years ago. We will build a stronger one now, but you see a dosing machine, which is usually often used by farmers to feed their cows. On the side you get feeding material coming out, and the whole row of cows can eat quickly, being fed quickly. Here it is used to directly feed not the cows, but the two presses which are put here, and the presses have on one side a juice coming out, and on the other side the fibers coming out. The fibers are grass silaged fiber that will be put into silage heap, and are very well protein poor fibers for normal cows. And the juice, which is protein rich, will be taken off its proteins in a simple system and can be fed directly to high productive cows. As you see, this whole machine with its electricity steering thing, I don't know, a steering chamber, can be put on a large truck to be sent towards dairy farmers which want to do this, and we have done some calculation. It can be profitable even for farms in which nitrogen losses are made. We can calculate that. Here you see the press working, being installed at a place near the factory, and working at our roadside grasses, which is not the very fresh grass which you see here from the farmer. but it can also split roadside grasses into protein-rich streams and fibers, and we are working on insulation material now. So this is a working technology. It works with 10 tons per hour. Here you see grass being mown, and here the splitting. I hope you can follow my, do I need to get, maybe. Oh, I hope. Well, I'm sorry, it's difficult to show you, but in the midst of this dia, which I will put again in place. Oh, sorry. In the midst of this called biorefinery pressing technology, you see the press. On the left side, you see the juice coming out. On the right side, you see the fibers coming out. And as you can see, we make several products out of both. It's being, I don't go into that now. It's working on freshly cut grass and crushes the grass with very strong power, 80 bars, into the cell moisture coming out, being a nitrogen-rich juice, and can be split into lower kalium-rich streams and protein-rich streams. And then the rest is a fiber which can be very well eaten by cows directly or being silaged for its quality. We use it usually in the third, fourth grass cuts. That means that half of the grass can be split half. I didn't mention it, but it's half of the nitrogen which can be split out. Here you see some production locations where we are working now, and on the Marke, it's in the region of Zwolle, which is in the midst of the east of Holland. As you can see, we put some of the moisture sometimes in small quantities, but usually in big containers. And here and below you see a picture where the green product is coming out. A lot of research for the quality of these both materials that's not too much our work, but it's been done by several occasions because our colleagues, they have done a lot of work in it, and also organic research, LBI and the Wageningen University have done a lot of research for the quality of the feed juice, stream, protein-rich, and fibers which come out. They can be very well fed without any loss. It's improving the feeding system and the efficiency. I think Professor Peter Jong will find this very interesting in terms of efficiency. We are using same machines for this production. It's not which we make insulation material and some other substrates. We think we need to try to get a demonstration, a VIDA demonstration, because, and we are now working, our company, Eco-grondstoffen and Rijntech, we are working to communicate with the Marke, with the farmer groups, with the farmers organization, LTO, and our ministry, because N-loss diminishment is very hardly needed now. The Netherlands has some highly necessary nitrogen regulation problems. It is being stopped by the law, by the highest justice, highest, I can't find the word now. And it's regulated to stop a lot of building projects, to stop a lot of dairy farmers to, because they can no longer grow their farms. It's a lot of problems, so we think might help if farmer organizations wanted to present themselves towards VIDA. We are working very hard on that. And I hope you understand what I've been trying to show you. Here you see the names of the organizations, Frits van Bergau, the CEO of Rijntech, Swier van de Vechten, the project leader of the Marke, Karel de Vries, Courage, which is working very hard to introduce new innovative systems into the dairy farmer groups, and the Ministry of Agriculture. Not mentioned is For Farmers, a very large farming organization, which is also very interested in this kind of work. I thank you very much for your attention, and hope that we can be able to work to help working on more profitable, more green efficiency, as Peter de Jong showed us in the chain of dairy farming. Thank you very much for your attention.
Emma, for your speaking, and I hope that you will find a solution with the national regulation as soon as possible, and you will be able to participate in the demonstration voucher. I think that you have also shared that information in VIDA working groups, and you were looking for a end user, isn't it?
Maria, the end user are the groups of farms and are the farming industry, and is at this moment the whole sector, because they risk to be cut by 40%, and this is a 25% diminishment of nitrogen for all the farms that don't want to be cut. So I don't think we can stop this necessity to diminish farming. There's a lot of farming, there's a lot of works going on in the Netherlands, and we definitely have to find lesser projects, etc. But I do think this is a solution for some farms. And yes, thank you. We would like to get their real requests more clearly on paper and sending it towards you to do a second demonstration request.
I remember to all participants that you can use the chat for your questions, and for the last presentation, it's from Cost Agents about improving the product value of whey, but by decreasing fluoride levels. So I'm going to start your presentation, and now, Hurt, you can begin. Hurt?
Thank you very much, Maria, for the introduction. Can anybody hear me? Just to confirm.
Yes, we can hear you.
Yes, we hear you.
Okay, great. Thank you very much. I will try and minimize my speaking time to 5 minutes. My name is Joost Edens. I work for the company VIDA Water Technology. And this, whoops, how is this, did I do this? Okay, let's go, I'm going to take it back to the start. Oh, somebody else did it? Okay, great, thank you. I will present a solution that we are going to implement in a dairy factory, and I believe can also be of interest in other similar kind of applications in the milk industry. So first, a little bit about the company. VIDA Water Technology has been around for 40 years. And what we do is that we manufacture salt electrolysis machines. I will not go too much in detail of this machine, but basically we use sodium chlorine or potassium chlorine, which is saturated in water, and by the usage of a anode cathodes being split into a disinfectant. The company has 2 own offices. and has a good installed base, and it's part of the prominent group. They have also a few other items in their product catalogs, like for example dosing pumps that might be familiar to some of you here present this morning. We are active in various industries, but if we're focusing in on food and beverage, it's mainly either the product, process or utility water. And in particular, this case, chlorate, I will come to that in a moment, what that is important when dealing with the one of the first two processes, the product or process water. So what is the issue? What is the challenge that the food and beverage brought, but also definitely the dairy industry has? It's a disinfection byproduct. In quite some applications, industrial hypochlorite is being used. And or this is also known as bleach. And during the production of this, there is the release of an inorganic disinfection byproduct. And depending on what type of disinfectant based on chlorine you use, you can have a different concentration of the disinfection byproduct. What is the most important byproduct? That is chlorate. You first have an oxidation of the OCl to chlorate, ClO2, but that moves on to chlorate, ClO3. And although the WHO is recommending a maximum concentration of chlorate in drinking water, they have not really set a clear standard or have not done really clear examples, studies of what the impact of chlorate present in food is. Hence what happened is, well, something that may cause a potential risk has been discussed within the food industry, and has been set to a much more stringent value as the WHO recommends in drinking water. So they allow in drinking water 0.7 milligram per liter of chlorate. I expect that the new limit in Australia will be set to 0.3. The health recommended limit by the Environmental Protection Agency is 0.2. But there's a trend here. It's getting stricter and stricter, and what happened is that a new norm is being formulated for baby food applications, where it is said to be okay. Let's try name for 0.01 milligram per kilogram of chloride. This is a significant factor for the dairy industry. Possibly Peter, you can comment on that more, but the milk is being partly is processed. You have whey as a side product. Now that used to be of relatively low value until the dairy industry found out that by processing this to milk infant powder, this was actually very high value that could be brought back into the dairy sector and being brought back to its stakeholders, the farmers. And if they are not able to match this, to come closer to this norm, it can be possible that no longer the whey can be processed as infant milk powder. Next slide. Yeah. So, what is our invention? Let's say. I briefly explained the process before. We are splitting. Oh, here's a nice arrow. How can I make it work? Okay, I don't know. We are splitting first line in the slide. We're splitting the sodium chlorine into chlor. We extract that as gas under negative pressure and redissolve it in the water phase. And either we dissolve it in, let's say, pure water in the pH of around 6.5, 7, or we dissolve it in a water phase where we have added caustic at the pH of 12.5, 12.7. And what that does is that extracting this chlorine gas and redissolving it in this high pH value is reducing the chloride that is being formed when you are redissolving the gas into the water to a very, very low minimum. For comparison, these are the values. Okay, that's very nice. But for comparison, what happens with industrial bleach? You have around 4% of the disinfectant is chloride, and this way we have around 0.01% if we maintain this pH level, or 0.07% of chloride. So it's a drastic decrease of this andesite byproduct. If we look at the situation of a dairy farm, this is an existing location where they are currently processing water from whey, and they use it as processed water. They find in a product a chloride level of 0.33 milligram. This is significantly, well, it's a factor 33 higher than the EU norm, and very difficult for them to maintain selling as a infant milk powder product. We expect that with this invention, the product quality improve will be to go to a chloride level of around 0.08. It's still 8 times higher, but at least it's not 33 times higher, so we're making a factor 5 of difference. Now the VIDA application also asks for, okay, what is the impact in water and energy efficiency? If you're using as source solid salt rather than industrial bleach, why is this happening? Sorry about this. Okay. Yeah. You're having a significant reduction in the transport that is needed. Instead of processing 100% weight solid of salt, of which you use roughly half of it as chlorine, you're transporting 12.5% of liquid in the conventional way. On top of that, industrial hypochlorite is deteriorating over time, and it deteriorates, it oxidizes basically to chloride. So what you want to do is to keep in as fresh as possible the industrial hypochlorite on site. And this no longer is needed, of course, if you're just storing the stabilized salt. So the transport reduction is not only in the amount of liquid that you have to transport, but also the actual movement that you need, because you can easily store for years salt on site and it will not deteriorate. Nothing is going to happen. Now, I think I have just made it very briefly. It was supposed to be pitched. How does the product look like? What is this machine? Is this ready? Yeah, yes. We have installed this machine in about 150 sites. So it's not new to us. However, the environment of disinfecting whey processes is new to us. So there are a couple of uncertainties that are related to the project, but it will depend a bit on the exact application, what those are. So I will leave that for now out of the pitch. Yeah. Thank you very much for your attention.
For presentation about this new methodology for disinfection processes, since I know that byproducts from chlorate compounds are getting more the interest about these pollutants is constantly increasing. So Peter de Jong has added some comments to your presentation. Maybe Peter, do you want to add something to this presentation?
Well, not really. It's just some information, because my name was mentioned in regard to waste, so I just get some additional information.
Any presenter wants to make a question to the other speakers about their presentation? Question for Peter de Jong. You have presented several innovative solutions for the milk sector. Please, can you tell us what's the technology readiness level of them in general? Peter, do you hear me? Hello?
Yeah, I hear you, but I'm not sure if I understood you correctly. You asked me something?
What solution for the
Yeah, you are not. I cannot hear you very clearly, to be honest.
Maybe it's better if please if you mute your microphone.
Yes, I switched on my microphone.
Yes.
Can you hear me?
Yes, but we both have the microphone now. I think that maybe now it's better. Several innovative solutions for the milk sector, and I want to know the technology readiness level.
Yeah, I understand. Now, the separation process to start with, I think is rather high. It's already implemented in the industry. If you look at the fractionation part, using membrane systems, so to fractionate between several whey protein fractions, for example, that's current under development. That's, let's say, in demonstration phase. Regarding this heat treatment, this very short one with very high temperatures, that's under development yet. I think we are trying now to build a pilot plant. So yeah, I'm not knowing the TRL level by heart, but we are ready to make a pilot plant. So that's clear. If you talk about the computer model-based process control together with sensors, yeah, that differs. It's applied already in partly. You can say it's in a demonstration phase. If it is on cleaning, so that the cleaning part of the equipment, So you can control with the simulation models, and together with new sensors, so not only conduction, connectivity measurement, but also sensors that can measure inline calcium, for example, or turbidity. That is all being applied, but not 100%. Just a few cases. So that's roughly the TRL level at this point.
Peter, it's 20 minutes late, so we are going to finish this webinar. Thanks to, first of all the speakers, and also thanks to the audience. And I remind you that we have the next webinar the next week, the 2nd of October, focused on energy efficiency in the food industry. So thanks to everybody, and hope we will meet again the next week. Thanks. Bye.
Bye, Maria. Thank you very much.